All right, the newest unit we are getting ready to start is dealing with algebraic expressions and distributing and simplifying and solving a different equation. So there's a lot going on in this chapter and it's got a lot of intense stuff in it. So we have to start at the very beginning, and this is something you've never seen before because 7th grade does not go through this. So pay careful attention and make sure that you're understanding what's going on. The very first thing we are going to do is to discuss the parts of an algebraic expression. You should now know that algebraic expressions are expressions that are made up of letters, numbers, and symbols, right, all connected together. Well, and that's what makes them algebraic. But there's different words that also go along with this that we have to be able to break them up into. So for the first part of this, we're going to do some definitions, and those definitions are what's going to help you be able to answer the questions that you're going to see below. All right, so the first word we're going to define is one that I've already said, but now we want to write it down. And that's your algebraic expression, right? And that algebraic expression contains variables, numbers, and at least one operation. Okay, if it only had numbers, it would be known as a numerical expression. So the fact that the letters are thrown in is where the algebraic part comes from. All right, so along with this, the first word we want to make sure we know, and you should know this word because you've heard of this one more than once, right? And that's a variable. And a variable is simply a letter that represents a number. And in algebra, it will always be lowercase. You cannot use capital letters. Capital letters are reserved for geometry class. All right, so there's the variable. The next word that we want to define is going to be the word coefficient, which some of you may have heard of this word before, but not necessarily used in the same context, right? And a coefficient are the numbers right in front of the variable. So they are connected to that variable, and they will always be right in front. You'll never see them anywhere else. Okay. The next word we're going to run into is the word constant, and you've heard of this in science in a way. Constants are things that never change. So in math, a constant is a number that will never change, right? So it is simply a number without a variable. The number 2 will always be the number 2 because it has no variable attached to it. But as soon as you put 2 times x, the value is going to change because of that x. All right, then the last two are the ones we want to be very careful with because they're the ones that you're going to have to know the most about, okay? And that's terms, right? First and foremost, terms are your variables or numbers and variables that are separated by a plus or minus sign. Okay, so every time you run into a plus sign or a minus sign, you've switched to a new term. Okay, and along the same thing as terms, there are things known as like terms, and it's exactly as it sounds. These are terms that are like each other, but in order to be like each other, here's what they have to have in common. These are terms with exactly the same variable, exponent, or no variable at all. Okay. All right, so now that you've got all these definitions down, let's start making some use out of these and showing you what you're going to have to do with them. I am going to put an example up here that is an algebraic expression, and we're going to dissect this expression and pull it apart into all these variables and all these words that we just talked about. Right? So I'm only going to do one of these with you here because you will do a bunch more on the chart that you've been provided, right? But the one that I'm showing you should serve as a model of how to do this, right? So here's what it's going to start off looking like, and it's going to have a lot of stuff in it. Okay, that's what makes it an algebraic expression, is that there's a lot of pieces to it. Okay, and your job is going to be to pull apart all the pieces and label them according to what they need to be. All right, so there's our expression. Okay, we know it's got letters, numbers, and signs, so we know it's an algebraic expression. The first word that we want to pick out, okay, is the variables. And in this problem, there's actually two of them, right? And variables are your letters that stand for a number. So the two letters that we have are the letters X and Y. Okay, so that part's done. Nobody should be messing up on the variable part. Right? The next part we want to do are the coefficients. Okay, and your coefficients are the numbers that are right in front of those letters. So if I see that there's an X right here, then right in front of it is that 6. 6 is a coefficient, not the X, just the number. If I find that there's a Y right in front of that, that's a positive 4. The plus sign goes with the 4. Okay, so that tells you what kind of 4 it is. So that means 4 is another coefficient. Then I keep looking and I don't come across another letter until I get down to this Y back here. And if I look right in front of it, there's a 3, but it's not just a 3 because the sign goes with the number that it's attached to. That is a negative 3 as a coefficient. Okay, and then when I go to the X in the back, right in front of it is a positive 2, so that means positive 2 becomes my coefficient. So there are 4 coefficients in this problem because there are 4 letters, right, that are stuck in the expression. All right, the next thing we want to take a look at are your constants. These are the numbers with no letters at all, right? The numbers that will never change, right? So if you look through and you try to find a number that has no letter, there's only one right here, and that's this negative 2. Remember, the sign in front of the 2 goes with it and tells you whether it's positive or negative. So negative 2 is the only constant in this problem. All right, for the next part, we want to actually list all the terms in this problem. And remember, your terms are separated by that plus or minus sign. All right, so we're going to literally go from left to right and keep them in the order that the problem has them in. You don't need to rearrange them at this point. All right, so as I go from left to right, I've got 6x. Right, I'm going to switch color so that you can see what I'm doing. 6x is one term. Right, then I have positive 4y before I hit another minus sign, so that's another term. Then I have negative 2, which is another term. And then I have negative 3y, all that is a term. And then I have positive 2x. So you'll notice that those plus and minus signs are separating the terms in this problem. This problem has 5 terms to it. Okay, and you do have to have all of the signs right as well as all the terms right. All right, and then the last vocabulary word that we were dealing with are the ones that are called like terms. Okay, and remember, these are the ones that are like each other for whatever reason. So if you look in our previous list of terms, the ones that are like each other are going to be the ones that have the same variables. All right, so we have the 6x and the 2x. Nobody else has an x. So in terms of like terms, 6x and 2x are a group. Okay. And then if I look again, I see some more things that are in common. The 4y and the negative 3y are like terms because they both have a y. So when we have another group, we have to say and then list the second group. And the second group would be 4y and negative 3y. Now negative 2, that little constant in the middle there, does not have anybody else that's like him. So he doesn't go under like terms. He just is not part of the like term category. Okay, so you've got to be careful and you've got to learn your definitions, okay, because that's what's going to help you the most. All right, but you will also do the chart that goes along with this and see if you can understand from those examples what you're missing out on or what you're doing okay with. The only last thing I want to leave you with a reminder is over here on the side, go ahead and put yourself a little star. Okay, if you have the problem, let's see, negative x plus 2, okay, and you're asked to find a coefficient. Every time you have a variable, you have a coefficient, but in algebra, some things like to hide from you a little bit. They become invisible, right? So in this problem, x is your variable. Your coefficient is a hidden 1 right here, right? So the coefficient of this guy is negative 1. All right, so you will not see 1s written at all. So you have to know that if there's not a number there, it doesn't mean it's 0, because you'll never see 0, okay? But the 1 is what's invisible. So if I have the problem 7 plus x, okay, I see my letter x right here, right? But there's no number sitting there in front of it that you can see. It's there, it's just a 1. So your coefficient to this one is going to be a 1. So the 1s are invisible. You've got to watch out for those. Otherwise, you're going to see the numbers that they want you to have. You will never have a coefficient of 0. because then you won't have any letters. Okay, but you can have 0 as a constant, and that's okay. All right, now to switch to the second part of what we're going to be doing. All right, the first part was dealing with the parts of an algebraic expression. All right, the next thing we want to talk about is something called combining like terms. So now that you know what like terms are, and this is part 2, by the way, we want to take a look at how we can combine them. There's absolutely no reason for you to keep such a problem as long as the last one that we did. All right, we can simplify them by combining things together that can go together, and that's where these like terms come in. All right, so before we even show you some of these examples, you want to take and make sure that you know that only like terms, and that like word is very important, may be combined. And when we're combining, we're adding or subtracting. All right. So I'll show you what this looks like. All right. If we have the problem 4p minus p, I'm starting you with some short ones so you can see what I'm looking for, and then that way you can kind of catch on what's going on. You have a coefficient of 4, and then remember what I just said about the fact that here's a p, but there's no number in front of it. There's technically a 1 right here. Right? So what you're looking at is 4p minus 1p. Well, if you think about this not in letters, but in things that you can relate to, think about it as 4 pennies and 1 penny. If you have 4 penny and you take away 1 penny, you're going to have 3 pennies left. So the only thing you're changing is the coefficient. The variable will stay the same. Right? So the answer to that one is 3p. We've simplified it, right, by combining. Right? The next one, if we have 6 plus 3n minus 8n. You can only combine the terms that are like each other, right? So 6 is not like anything else because it doesn't have a letter, but the other two are like each other. Positive 3n and minus 8n are like each other because they both have n's. So you do exactly what it says, 3 minus 8, right? That makes negative 5, and then put the n. Now the 6 that's up there has nobody to go with it, so it doesn't just drop out of the problem, it just goes into the back. And the 6 is a positive 6 where we write plus 6. The order when you write your final answer should always be alphabetical, and the variable term should always be first with the constant last. All right, so make sure you kind of get in that habit with the order of things as well. All right, so let's take on another one and see if you're getting any better at it. 2g minus 3 plus 11 minus 2g. All right, so here's our next one, and then we're looking for like terms first. Always start with your variables first. Since you know they're going to go in the front of your answer, you might as well get those out of the way first. All right, so if I'm looking for variables, I see 2g's here. This one is a positive 2g. This one's a minus 2g. So when I go to do this, 2g minus 2g makes 0, but you can't say 0g. So basically what's happening is this 2g and this negative 2g cancel each other out. There are no more g's in this problem. Right? So now what you're going to combine are these constants right here in the middle. Negative 3 plus 11 produces a positive 8, and that's all your answer is going to simplify to because everything else combined or went away. Okay, so you're combining the things that are like each other to produce an answer. All right, for the next one, 5x minus 2 minus 7x plus 6. Okay, we're taking a look again with the variables first, so we want to start with our x's. Okay, so that means 5x will join with minus 7x. All right, take your integers, 5 minus 7, that's negative 2, put the x behind it. Now, the rest of it, negative 2 and positive 6, those are just numbers, those are constants. They're like each other because of that reason. So negative 2 and positive 6 can join each other. Notice how I'm using circles and squares to help separate my terms so that when I look at this problem, I know which ones to join together. You would never join a circle with a square because they're not like each other. Okay, so negative 2 plus 6 is going to make a positive 4. And there's our answer to that one. All right, we'll do one more under this category, and then we'll switch to the third part and the last part of our notes. All right, and this is what we'll be spending the next couple of days on, is all of this stuff. All right, so you're not going to get over this and just move on in one day. All right, this takes a couple of days to understand and digest all the way through. All right, here's the next one, and it's got 5 terms to it, so there's some stuff we can combine and some stuff we can't. All right, so let's start with our variables. I see the letter K there, and no other letters of the alphabet, so that's got to start with K's. This is negative 3K. Then I see a negative K right here, but remember the number that goes with it is that invisible 1 that you can't see. Okay, and then this is a positive 5K. So when you're trying to combine 3 of them together, you literally just go left to right and then merge it together to make 1. Okay, so -3 minus 1 is -4. -4 plus 5 produces 1k. Now you can write the 1 or you can write it just like this because they both mean the same thing. Okay, and then if you notice what's left, I've got +8 and -6. Those are constants. They go together because they're like each other. 8 minus 6 produces a +2. That's the simplified answer to the problem that we just started with. Okay. All right, the last topic we're going to deal with, okay, is simplifying using the distributive property. We just did combining. Now, up until now, all you've had to do with the distributive property is be able to recognize it. Well, in this chapter, you're going to have to be able to use it, right, to get your answers, right? So the first thing we want to take a look at is what is the distributive property showing us, right? And basically, this is when you have a number outside the parentheses that gets multiplied by each item inside. Okay, so the number outside has to be given. That's what distributing means, is that you're giving it to everybody. And the way we're going to do this is by multiplication. So here's what you've got to keep straight. Combining means add and subtract. Okay, distributing, though, you're going to have to multiply to get your answer. All right, so we'll take a couple looks at these, and then, again, we'll practice lots in class. All right, so for the first one, if we have 4 on the outside of x plus 9, okay, the distributive property says that you're going to take that 4 and you're going to give it to the x and the 9. Right? I draw arrows to help me make sure that I'm not forgetting anybody. Right? So I highly encourage you to do so as well. 4 times x, because remember this is all by multiplication, is 4x. Right? But then we want to do 4 times 9, and here's what you've got to watch out for. This is a +9 right here. So 4 times +9 is a +36. Okay, so you're physically doing the distributive property. You're not just picking it out of a set of problems. All right, so for the next one, if I have y minus 2 in parentheses and the 4 hanging out in the back, the number you are distributing can be in the front or the back. Typically, it's in the front, but every now and then they sneak one in the back to try and throw you off. Don't let them. All right, so this 4 is touching the parentheses, so I know that's the one I want to distribute. I'm going to go always to the front first. 4 times y produces 4y. And then this is a -2. Make sure you're using the sign. 4 times -2 is -8. Okay, so these signs are going to be super important, especially as we start getting more things mixed in, like in this next one. If I have -6 on the outside and p minus 5 inside, I'm distributing a -6 to both pieces. All right, so here's what's going to happen. -6 times p is the -6p. That's the easiest part to do, right? But here's where things start going wrong for some people. This is a -5. So when I take a -6 times a -5, a negative times a negative produces a positive. 6 times 5 makes 30. Okay, so you've got to watch out for your signs because it will change that middle sign depending on what's happening. Okay, I've got 2 more to show you, and then I'll let you practice in class to see where you're still not quite getting it. All right, so here's the next one. Okay, we are distributing the 3 to everybody, right? And then we'll see what's left. Right? So if I have 3 times 2x, right, that means I'm going to have 6x. You still multiply the 2 numbers together. You just keep the letter. Okay, and then this is a -4. So 3 times -4 is going to be -12, or -12 right there. Okay, so that's going to be your final answer. Right? And then the last one I want to show you is one of those weird tricky ones that people tend to forget about, but if you know enough about what you're looking at, you won't fall guilty to it. Right? Every time you see parentheses with 2 things inside of it, okay, you have to distribute something. Right? So in this problem, I see the parentheses and I see 2 things inside of it, but I don't see a number outside to distribute it to. Remember in algebra that there is a hidden invisible -1 right there. That's what you're going to distribute. Okay, so now we want to take -1 times k, which is -1k, or you can just make it invisible like I did. Okay, and then this is a -5 right here, so this is -1 times -5, which turns it into a +5. Okay, so that is the same thing there. Okay, so be careful with those invisible numbers. Okay, don't forget about them. Right, but then make sure that you are multiplying in your distributive property.